Hello student, I am Dr.A.K, Professor of Chemistry. Today I am going to discuss hydrolysis of salts and the pH of their solution. Last class I have discussed polybasic acids and polyacidic bases. Also I have given idea regarding common ion effect in the ionization of acids and bases. Today I am going to discuss hydrolysis of salts and the pH of their solution. Here you should know that salt is formed from acid and bases. Acid plus base, that is equal to salt plus water. This is in general how salt is formed. This you keep in mind. Now I am going in details. Salts formed by the reactions between acids and bases in definite proportion undergo ionization in water. The cation and anion formed on ionization of salts either exist as hydrated ions in aqueous solution or interact with water to reform corresponding acids or bases depending upon the nature of salts. Means if you will add in water, then their ion, salt's ion, as for example NaCl, when it will react with, when you will dissolve in water, then water is H ion and OH ion, that you know. Then NaCl will interact with this water, and there are two possibilities. First possibility is that Na will be surrounded by H2O. Na ion, Na plus will be surrounded by H2O. Cl ion may be surrounded by H2O. That is called hydrated. Second, that this Na plus can react with water, can interact with water. Means Na is positive charge and H2O will ionize as H plus OH minus. Then oppositely it will go. Na plus will go to OH minus. It will form NaOH. Now NaCl was there. Then Cl minus will go to H plus. It will form HCl. Means NaCl can form NaOH and HCl. Means a strong acid and a strong base. Okay. Like that way other salt, KCl, MgCl2, barium chloride, all will react. Either they will react with water, means interact with water, or it will be hydrated means attachment with H2O, direct H2O. Okay. Then these things here you have to understand. Okay, that it will form acid or bases depending upon the nature of salts on addition of salt into water. Now further you understand that the process of interaction between water, the process of interaction between water and cation or anion or both of salts, okay, is called hydrolysis. When it will react with water, then it is called hydrolysis because it forms acid and bases. H2O is used up. H plus OH minus both will be used up. That's why it is called hydrolysis. Okay, and it forms acid or bases. then obviously pH, the pH of the solution gets affected by the interaction. pH, it will affect the pH of the solution. The cation, as for example, sodium ion, potassium ion, calcium ion, barium ion, etc. of strong bases and anions like chloride ion, bromide ion, nitrate ion, perchlorate ion, etc. of strong acids simply get hydrated but do not hydrolyze, and therefore the solution of salts formed from strong acid and bases are neutral, because salts are from the strong salts formed from a strong acid and a strong base. When it is dissolved in water, then again it will form a strong acid and a strong base. That's why it will be neutral. It will give neutral solution, and salt is called neutral salt. Question is asked in examination. However, for one thing you keep in mind, that pH for neutral solution is 7. pH for neutral solution is 7. However, the other category of salts do undergo hydrolysis. Okay, means a strong salt will hydrated. A strong salt will be hydrated, and other salt, weak salt will be hydrolyzed, means H and OH ion will be used up. But in case of a strong salt, that Na and as for example NaCl, Na plus Cl minus will be hydrated. Okay, water molecules will be attached. Now there are 3 types of I can say these things, hydrolysis. We now consider hydrolysis of the salts of the 3 types. First is that salts of weak acid and a strong base. Weak acid, salts of weak acid and a strong base. Then example is sodium acetate. Sodium acetate, acetate ion comes from the weak acid, acetic acid, and sodium comes from the strong base, NOH. Okay, then sodium acetate is the example of salts of weak acid and strong base. By seeing the salt, you can tell that which type of salt is there. Sodium acetate, then acetate ion will come from acetic acid, and sodium will come from NOH. That's why it is the salt of weak acid and a strong base. Another example, salts of a strong acid and weak base. Then example is ammonium chloride. Then here ammonia came from the big ammonium came from the big base, ammonium hydroxide. Ammonium ion NH4 plus came from the big base, ammonium hydroxide, and Cl came from the HCl, strong acid. That's why it is the example of salt of a strong acid and weak base. A strong acid due to the Cl and weak base due to ammonium, and salt is ammonium chloride. Third type of salt, that is that forms from weak acid and weak base. Both are weak, acid and base both. Then example is ammonium acetate. Then you can understand ammonium came from ammonium hydroxide base, weak base, and acetate came from acetic acid, weak acid. Hence salt formed ammonium acetate, that is the salt of weak acid and weak base. These questions what I told you now, these 3 type of salts, these are asked in examination. You have to find out which type of salt is there and why. Then I have already given explanation. In the first case, that is the sodium acetate being a salt of a weak acid, acetic acid, and a strong base like NOH, gets completely ionized in aqueous solution. Means here you can see sodium acetate will ionize in water, acetate ion and sodium ion, aqueous acetate ion and aqueous sodium ion. Acetate ion thus formed undergo hydrolysis in water to give acetic acid. Already told you that acetate ion plus OH ion from water, acetate ion plus H ion from water, it will form acetic acid, weak acid, and weak acid will be almost undissociated. It will dissociate very less, undissociated. And like that way, this Na will give NOH, then that is a strong acid. NOH, a strong base, NOH. Then finally solution will be basic because it forms acetic acid, that is the weak acid. It is very less ionized. And NOH is a strong base. It is ionized. More ionized. Then it is a strong base, and the entire solution will be basic, and pH will be more than 7. This you should remember, that in water, what type of solution will exist. If base will be strong, then solution will be basic, pH will be more than 7, and if acid is strong, in the solution acid is formed, then a strong acid is formed, then pH will be less than 7. Okay, then this you have to understand. Then I told you about the acetate ion thus formed undergo hydrolysis in water to give acetic acid and OH ions. Okay, then acetic acid plus H2O, acetate ion plus H2O. Acetate ion means CH3 COO minus plus H2O. It will form acetic acid plus OH minus. Acetic acid being a weak acid, Ka value is very less, 1.8 into 10 to the power minus 5. This remains mainly unionized in solution. This results in the increase of OH ion, because H ion has been used up by acetate ion, and acetic acid form is unionized, undissociated. Hence in solution OH ion will be there, that is the strong base. This results in the increase of OH ion in concentration in solution, making it you can say alkaline. Alkaline means basic solution is called alkaline solution. Here I want to tell you that there is a difference between base and alkali. Base which dissolves in water, is called alkali. Okay, all bases are not alkali, but all alkalis are bases. This you should understand. All bases are not soluble in water. That's why all bases are not alkali. But all alkalis are bases. That is granted. Okay. This you understand. Then this I told you, this results in increase of OH ion concentration in solution, making it alkaline. The pH of such solution is more than 7. Similarly, now see the effect of ammonium chloride. Similarly, ammonium chloride formed from weak base NH4OH and a strong acid HCl. NH4 plus HCl, it forms ammonium chloride. Okay, hence now if you will add in water, then again it will form same things. In water, this solid solid ammonium chloride, if you put in water, then again it will form, because in water H plus OH ion is there, then NH4 plus OH, NH4OH, and H plus Cl, HCl, it will form. Then NH4 is again big base, it will be unionized, very less ionized, and HCl is a strong acid, hence entire solution will be acidic and its pH will be less than 7. Okay. Then this ammonium chloride, I am talking about now again. Ammonium chloride formed from big base, ammonium hydroxide and a strong acid HCl in water dissociates completely and it gives ammonium ion and chloride ion, means NH4Cl, aqueous NH4Cl gives NH4 plus ion plus Cl minus ion in water. Ammonium ions undergo hydrolysis. Ammonium ion, it will react with the water and it will form ammonium hydroxide, means hydrolysis, it will go hydrolysis with water to form ammonium hydroxide and H ion and H ions. Then like this way, NH4 plus H2O. NH4 plus means ammonium ion plus H2O, it will give ammonium hydroxide plus H ion. Ammonium hydroxide is a big base and its value is 1.77 into 10 to the power minus 6 and therefore remains almost unionized because its K value is Kb value is very less. Kb value I told you 1.77 into 10 to the power minus 6. Therefore, ammonium hydroxide remains almost unionized in solution. Okay, then what will happen? In solution H ion is there, chloride ion is there, then it formed HCl and HCl is a strong acid, hence entire solution will be acidic and its pH will be less than 7. The pH of ammonium chloride solution in water is less than 7. Question is asked, ammonium chloride if you put in water, the entire solution will be acidic due to the strong HCl. It will form HCl with water. Okay, this I have told you. Now third example, that is the weak acid, a salt of weak acid and weak base. As for example, ammonium acetate. Ammonium acetate, both are weak. Acetate is coming from acetic acid and ammonium is coming from weak base ammonia. Hence it is the salt of weak acid and weak base. And it will ionize in water because it is a weak. Actually it is a salt of weak acid and weak base. The ions formed undergo hydrolysis. Means now acetate ion will go hydrolysis with water. Means ammonium acetate plus H2O. It will form acetic acid plus ammonium hydroxide. Both are weak. Then acetic acid and ammonium hydroxide also remains, you can say, in the solution both will be there and both will be undissociated. Hence finally solution will be, finally pH will be neutral. pH of the solution will be neutral. Okay. Then because this acetic acid will give acetate ion plus H ion and ammonium hydroxide will give NH4 plus OH ion. Then this H ion or OH ion, it will form water, H2O. This acetic acid, after ionization, it will give acetate ion plus hydrogen ion. And ammonium hydroxide, it gives ammonium ion plus OH ion. Then this H ion and OH ion, H plus OH ion, it gives H2O. That is the neutral. Hence entire solution will be neutral. This question is asked. Okay. Now one more thing you can understand. The degree of hydrolysis is independent of concentration of solution. In this case, salt of weak acid and weak base. Degree of hydrolysis is independent of concentration of solution because both are weak. Even if their concentration is more, degree of hydrolysis will not affect the degree of hydrolysis. Degree of hydrolysis is independent of concentration of solution, and pH of such solution is determined by their pK value. Ka, that is the pKa value. Then pK value, how will you calculate? pK value already told you. pH value, in this case, how will you calculate? Means in this case, in the case of a strong salt, a salt of weak acid and weak base, its pH can be determined by the value of pK value. How? Then pH is equal to 7 plus, formula is there, pH is equal to 7 plus half of pKa minus pKb. pKa minus pK, difference of both, divided by 2. pH is equal to 7 plus pKa minus pKb divided by 2. Okay, this is the formula. The pH of solution can be greater than 7 if the difference is positive. If pK is more and pKb is less, then it will be positive. pK is more and pKb is less, then pKa minus pKb will be positive value, that is divided by 2, then pH value will be positive. Okay, and it will be less than 7, means pH value will be more than 7 if pKa minus pKb divided by 2 will be positive, means if pK is positive and pK is more and pKb is less, then obviously it will be positive, hence pH value will be more than 7. And when pKb value is more, pK is less, then it will be negative, then pH value will be less than 7. Okay, if pKb value is more than pKa, means pKb minus pKa minus pKb, this is the divided by 2, 7 plus half of pKa minus pKb. Then if pKa value is more, then pH value will be more than 7, means basic, solution will be basic. If pKb value is more than pKa, then it will be negative, then pH will be less than 7, because 7 minus something, hence it will be less than 7, then solution will be, pH value will be less than 7, that is the solution will be acidic. Okay, then this I have told you about the these things, salt of hydrolysis of salts and the pH of their solution I have told you. Now I will give you idea about buffer solution. What is actually buffer solution? Then you try to understand. Buffer solution, many in our body I am talking about, many body fluids, as for example blood or urine, have definite pH, and any deviation in their pH indicates malfunctioning of the body will not work normally. The control of pH is also very important in many chemical and biochemical reactions. It is very, very important to control the pH. pH should not change. Many medical and cosmetic formulation requires this many medical and cosmetic formulation require that their means pH must be kept constant and administered at a particular pH. Many medical and cosmetic formulation requires that these be kept and administered at a particular pH. Then how will you define the pH? The solution which resists change in pH. That type of solution, one solution is there, keep in mind. Okay, the solution which resists change in pH on dilution, means if you put little water or with the addition of a small amounts of acid or a small amount of alkali, are called buffer solution. Means that type of solution in which if you will dilute it, means if you will add some water, or if you will add some acid, or you will add some you can say bases, then its pH should not change, or very minute change, very negligible. Okay, which resists the change in pH after adding a small quantity of acid or bases or little water, then that type of solution which resists the change in pH is called buffer solution. Okay, buffer solution. And this known pH, how will you prepare this buffer of known pH? If you want to make buffer, then how will you make? Then buffer solution of known pH. Suppose you want to make a buffer solution of pH 7 or pH 9 or pH 10. In that situation I am talking about. Buffer solution may be of different type, different pH value. Then here buffer of known pH can be prepared from the knowledge of pKa of the acid or pKv of base, and by controlling the ratio of, second thing, first by knowing the pKa value of acid or pKv value of base, that is a requirement. And second requirement is that the ratio of the salt and acid or salt or bases. Salt is common, you require salt. You require salt and acid. Salt and acid also you require of the same salt. In the salt, acid will be, it is formed from the acid and base. Then for acidic pH I am talking about, that salt plus acid. Okay, or you can say here acid and the salt of the same acid. Acid plus salt of this acid which you are considering, their ratio, means ratio of salt and acid or salt and base. This you have to control. Okay, then after that buffer solution will be ready. Okay, again I am telling you, buffer of known pH can be prepared from the knowledge of pKa of the acid or pKb of the base or salt. Okay, and that is the already told you pKa of pKa of the acid or pKb of base, and by controlling the ratio of salt and acid or salt and base. This ratio you have to control. Okay, a mixture of acetic acid, example I am telling you, a mixture of acetic acid and you can say sodium acetate. See, here this is the example of buffer solution. Mixture of acetic acid, that is the acid, and sodium acetate, means salt of this acid, salt of acetic acid, that is the sodium acetate. This is the example of buffer solution. A mixture of acetic acid and sodium acetate acts as a buffer solution around pH 4.75. Okay, it will produce a pH 4.75. It will work. A mixture of acetic acid and sodium acetate acts as a buffer solution around pH 4.75. This value should know. And a mixture of ammonium chloride and ammonium hydroxide. A mixture of ammonium chloride, this is salt, and ammonium hydroxide. We are talking about the base. Okay, a mixture of ammonium chloride and ammonium hydroxide act as a buffer around the pH 9.25. Basic. 9.25 means basic. And here I told you acetic acid and sodium acetate, that is the acid. Then that's why it will function as a 4.75. This is the acidic. And now I told you ammonium chloride and ammonium hydroxide. This is the basic buffer, and it will function at near about pH 9.25. Okay, this I have given idea about the buffer solution. Okay, buffer solution. And two things I have discussed today: hydrolysis of salts and the pH of the solution. And second things, buffer solution I have discussed. Now I am going to discuss you can say some numericals. Okay, numericals is also very, very important. Then in these numericals are based on what I have discussed theory on that. Okay, question I am telling you, problem, just to listen. Numericals is like that. Numerical is also called problem. Okay, then question is like that: determine the degree of ionization. Degree of ionization means alpha. Determine the degree of ionization and pH of a 0.05 m ammonia solution. The ionization constant of ammonia can be its value is fixed. Ammonium value, K value I am talking about, that value for the ammonia it is fixed, and its value is 1.77 into 10 to the power minus 5. Okay, it means its value is given. Ionization constant of ammonia is given 1.77 into 10 to the power minus 5. Okay, and also calculate the ionization constant of conjugate acid of ammonia. Ammonia is base, you know. Then pH, you have to calculate the ionization constant of conjugate acid of ammonia. Then here what is given, I am telling you again, reading the question: determine the degree of ionization and pH of 0.05 m of ammonia solution. The ionization constant of ammonia is given. Also calculate the ionization constant of the conjugate acid of ammonia. Then first, how will you calculate, you can say, degree of ionization and pH? First you understand three things you have to calculate: degree of ionization and pH of the given ammonia solution. Means ammonia solution value, molarity value is given 0.05 m. Okay, that is the initial concentration is given. Then three things you have to calculate: first pH value, second alpha value, third you can say these things, ionization constant of the conjugate acid of ammonia. Three things you have to calculate, and ionization constant of ammonia they have given. Then now how will you calculate? Just I am solving, just you listen carefully. See, the ionization of NH3 in water, first you have to write NH3 plus H2O, you have to write. Then you know NH3 plus H2O will be NH4 plus, means ammonium ion plus hydroxyl ion. This is the reaction in water. NH3 plus H2O is equal to ammonium ion plus hydroxyl ion. Now here hydroxyl ion concentration. Here hydroxyl, I have already told you that this value ammonia, ionization constant of ammonia is given in question. Then now here solution concentration is given 0.05 m. Okay, that this solution concentration is given 0.05 m. Okay, ammonia solution concentration is this, means NH4, now it is breaking into NH3 plus H2O, ammonium plus hydroxyl ion. Then now what will be the concentration of OH ion? Then suppose it is alpha is dissociated, means out of 0.05 m, alpha is dissociated, alpha mole. Then obviously alpha mole hydroxyl ion will be formed, and alpha mole ammonium ion also will be formed. But here you have to consider, give importance for hydroxyl ion, OH ion. Then here hydroxyl ion concentration will be C into alpha, but here C is equal to 0.05 m. It means C into alpha means 0.05 m into alpha. That is the OH ion concentration. Correct? Ammonium ion and OH ion both will be alpha. Then means alpha of 0.05 m. Then 0.05 m alpha ammonium ion will form, and 0.05 m into alpha or 0.05 alpha, that is the OH ion is formed. Okay, and ammonium ion constant, this ionization constant is given. Then now very easily you can write, Kb is equal to expression, how to write. Kb is equal to 0.05 alpha square. Already told you, C upside, C downside, it will be cancelled out. Then direct value I am writing here, 0.05 alpha square divided by 1 minus alpha, because 0.05 minus 0.05 alpha, then 0.05 will be common. Upside also 0.05 will be there. Then 1.05 upside, 1.05 down will be cancelled. Then 0.05 alpha square divided by 1 minus alpha will remain. Okay, this will remain. And here also that the value of alpha is small. Why? Because Kb value is very small, then obviously alpha value will be very small. Hence in the place of 1 minus alpha, you can write only 1. Because alpha value is very, very less in comparison to 1. Because Kb value is very, very less. Okay. Hence that 1 minus, in the place of 1 minus alpha, you can use only 1. Means down will be only 1. Then what will remain? Kb value is given. Kb value is given. Then it will be remain Kb is equal to C alpha square will remain, means 0.05 alpha square will remain, and Kb value is given 1.77 into 10 to the power minus 6 it is given, means 1.77 into 10 to the power minus 6, that is equal to C alpha square, means 0.05 alpha square. Then alpha value will be under root 1.77 into 10 to the power minus 6 divided by 0.05. 0.05, correct? Because 0.05 alpha square is equal to 1.77 into 10 to the power minus 6. Then alpha square is equal to what? 1.77 into 10 to the power minus 6 divided by 0.05. This is the alpha square. Then alpha is equal to under root. Then you will get the alpha value. Then alpha value you will get, that is the, after solving it will come alpha value 9.4 into 10 to the power minus 4 m. Alpha value means OH concentration. Now you are knowing OH concentration. Okay. Then OH concentration, now you got 9.4 into 10 to the power minus 4 m. Then when OH you are knowing, then H also you can know, H ion concentration, because H ion concentration into OH ion concentration is equal to Kw, means 10 to the power minus 14. Then now OH value you are knowing, then H value will be 10 to the power minus 14 divided by OH minus, and then OH minus value is already calculated, 9.4 into 10 to the power minus 4. Then after putting this value and calculating, then H ion concentration value will come, H ion concentration value will come 1.06 into 10 to the power minus 11. Then when H ion concentration you are knowing, then pH you can calculate very easily. Then pH is equal to negative logarithm of hydrogen ion concentration. And hydrogen ion concentration now you got 1.06 into 10 to the power minus 11. Hence after putting this value, you can calculate pH, and its value will come around 10 to the power 10.97. Its value will come 10.97. Okay, because hydrogen ion concentration is 1.06 into 10 to the power minus 11. Then after solving this with the help of logarithm table, you can, after putting the value, you will get the pH value around 10 to 10.97. Then see, you got the pH value. Okay, alpha value also you got, pH value also you got. Now third things you have to know, you can say third things, calculate the ionization constant. Calculate the ionization constant of conjugate acid. Okay. Then how will you come to know this thing? How will you calculate? Then now using the relation conjugate acid base pair. Conjugate acid base pair, that is equal to Ka into Kb is equal to Kw. This relation I told that time also, very important relation. Ka into Kb, that is equal to Kw. Then here Kb value is given. Kb value is given in question, that is the 1.77 into 10 to the power minus 6. Then now this Kb value you are knowing, correct, and Ka value you want to calculate. Ka into Kb, that is equal to Kw, and K value you are knowing. Kw value is equal to 10 to the power minus 14. Then out of 3, 2 you are knowing, 2 things you are knowing. Then Ka is equal to Kw divided by Kb. Then Kb is equal to 10 to the power minus 14. And Kb value is 1.77 into 10 to the power minus 6. Then after solving you will get, solving means what? Ka is equal to Kw divided by Kb. That is equal to 10 to the power minus 14 divided by 1.77 into 10 to the power minus 5. minus 5. That is the ionization constant of ammonia. Then after solution you will get 5.64. 5.64 into 10 to the power minus 10. That is the value of Ka. That is the value of Ka. That is the this thing. You have calculated Ka value means ionization constant of the conjugate acid of ammonia. Okay, this type of question is little hard, little not more, little hard, but this type of question will be asked or is asked in particularly for IIT Advanced. Okay. Now another you can say this question I am telling you. That question is again little long but full of concept. Question I am reading. Calculate the pH of 0.1 m. 0.1 m means m by 10. 0.1 m ammonia. 0.1 m ammonia solution. Calculate the pH after 50 ml of this solution is treated with 25 ml of m by 10 HCl, means both are same. M by 10 means 0.1 m ammonia, and here HCl is also same, 0.1 m HCl. The dissociation constant of ammonia is given same, 1.77 into 10 to the power minus 5. Okay, this is given. Kb is given 1.77 into 10 to the power minus 5. Then how will you calculate? Again I am reading the question. Calculate the pH of 0.1 m ammonia solution. Calculate the pH after 50 ml of this solution is treated with 25 ml of 0.1 m HCl, means acid base reaction. The dissociation constant of ammonia is given. That is the Kb value is equal to 1.77 into 10 to the power minus 5. Then again this you have to write the reaction. Ammonia is dissolved in water. Okay, or in solid there will be no reaction. Okay, always in water. Hence first you write the reaction. NH3 plus H2O, like earlier, it will form NH4 plus OH minus. Then first you have to find out the pH of 0.1 m solution. Then here Kb, K expression you can write. Expression is equal to Kb. Kb is equal to ammonium ion into OH ion divided by ammonia, concentration of ammonia. Okay, and its value is given 1.77 into 10 to the power minus 5. Then before neutralization, ammonium ion calculation and OH ion ammonium ion concentration and OH ion concentration you don't know. Only ammonia strength you know, initial concentration you know, and this after the reaction with water, how much ammonium ion formed, how much hydroxyl ion formed, you don't know. Then you consider X mole ammonium formed, X mole OH ion formed. Then how much ammonia will remain in equilibrium? At equilibrium, how much ammonia concentration will remain? Then that you know, that will be minus 1 this 0.1 minus X. 0.1 minus X, this type of question already you have solved. Okay, then now first you here what do you think that X, K, you know that Kb is equal to X into X. divided by 0.10 divided by 0.10 or 0.1 only write. Then here I told you 0.10 only you are writing, ammonium concentration is given 0.1 m only. Then Kb value is known, Kb is equal to x square divided by 1.0. Then Kb value are knowing, and down is 1, then obviously Kb is equal to x square. Kb is equal to x square, or x square is equal to Kb, and Kb value is given. Kb value is given 1.77 into 10 to the power minus 5. Hence x square is equal to this value, Kb value. Then x is equal to under root Kb, and Kb value is given. Hence you can know the value of x. Okay, then x value after this square root, taking the square root of this, x value will come 1.33 into the 10 to the power minus 3. This is the value of x, means value of concentration of OH ion, because x is equal to OH, and same things x is equal to ammonium ion also, but here you are interested with OH ion. Then why OH ion? Because you know that these things H ion concentration into OH H ion concentration into OH ion concentration is equal to 10 to the power minus 14. Then one you will know, other you can know. That's why OH ion concentration, knowing OH ion concentration is important. Okay. Then now OH ion concentration you got, x value you got means OH ion concentration you got 1.33 into 10 to the power minus 3. Then now H ion concentration you are knowing, OH ion concentration you are knowing. Then what will be the H ion concentration? Then now very easy, Kw divided by OH ion concentration. Then Kw value is 10 to the power minus 14, and OH ion concentration is, now you got 1.33 into 10 to the power minus 3. After solving, you will get hydrogen ion concentration equal to 7.5 into 10 to the power minus 12. Minus 12 we will get hydrogen ion concentration. Then when you are knowing the hydrogen ion concentration, then pH easily you can know. pH is equal to negative logarithm of hydrogen ion concentration, and hydrogen ion concentration is given, is calculated 7.51 into 10 to the power minus 12. Then after solving, you will get pH value, that is equal to 11.12. 11.12. Then now you got the pH value. You can this question you can consider in a two part. Okay, two part. Then first part you got the pH value. Now second part is that this ammonia solution 0.1 m ammonia solution, this calculate the pH. Again you have to calculate pH second time also, but condition is there, calculate the pH after 50 ml of this 0.1 m ammonia solution is treated with 25 ml of 0.1 m HCl, means acid base reaction. Ammonia solution now is reacting with HCl, both has same strength. Only difference is that ammonia is 50 ml you have taken, and acid is only 25 ml. Then what will, after the mixing both ammonia and this HCl, means base and acid you have mixed, then finally what will happen, whether solution will be acidic or basic. Then by common sense also you can understand that NH4OH is weak and HCl is a strong acid. NH4OH is a weak base and HCl is a strong acid. Both you have mixed. Then finally After the reaction, what will happen? Because HCl is strong, hence in the solution HCl will be there. It is more ionizable. That's why finally solution will be acidic. But here one confusing things are given. 50 ml they have taken ammonium hydroxide and 25 ml only HCl, and both solution has same strength, 0.1 m, 0.1 m. Then this is the doubtful, but here in one look you can tell finally solution will be acidic. But here try to understand how. Then here you know that because acid strength is same, then 25 ml HCl will react 25 ml ammonia, and 25 ml ammonia will remain. 25 ml ammonia will remain. Acid and base, 25 ml acid is neutralized by 25 ml base. But in this after this 25 ml ammonia will remain. Now it is confusing. From the one angle it looks that solution will be finally acidic. But now 25 ml acid and 25 ml base is neutralized. Then 25 ml ammonia will remain. Then after the solution only you will come to know that what is the base solution is acidic or basic. Okay. If acid solution was more, then okay, there was no need to solve the problem. By seeing only you could have told that solution is acidic. But now acid is less and base is more. Now see how will you prove it, how will you calculate. Then now a reaction is between acid and base, means ammonia plus HCl. It will give ammonium ion plus chloride ion. Okay. Then 2.5 ml ammonia reacted with 2.5 ml HCl. Then in the beginning ammonium ion was 0, chloride ion was 0. But at equilibrium what will happen? When both will react, then ammonia will finish. In the beginning initial concentration of ammonia was 2.5. It was you can say 50 ml. We have converted actually into millimole. Okay. Then 50 milliliter. Millimole means 50 ml into a strength you multiply. Then you will get millimole. 50 ml 0.1 m ammonia. Then you multiply. That is called millimole. Then it will become 0.5 millimole. Like that way acid is 2.5 into 0.1. Acid strength is 0.1. Then it will be 2.5 millimole. Okay. This is the unit, nothing else. Then from the 5 millimole to 2.5 millimole of ammonia will react with 2.5 millimole acid. Then now 2.5 ml ammonia is remaining. Okay. After the reaction. Then at equilibrium what will form? After the reaction ammonium will form 2.5 and chloride will form 2.5. Ammonia 2.5 ml plus HCl 2.5 ml. If both will react, in the beginning its concentration was 0, but now at equilibrium ammonium ion will be 2.5 and chloride ion will be 2.5. Okay, both will be 2.5. Okay, because they are making only reactant is only 1 mole, 1 mole ammonia, 1 mole chloride, means coefficient is 1, hence both will be equal. Now again you think NH3 that you have taken ammonium ion is 2.5 and chloride ion is 2.5. But what is the now new things you have to understand? That remaining ammonia NH3 that will react with water. Remaining 2.5 ml ammonia will react with water. Okay, and that will form ammonium ion. That NH3 will form ammonium ion. NH3 plus H2O. Ammonium ion it will form. Okay, NH4OH it will form. Then NH4OH will neutralize, it will ionize in water, NH4 plus OH, ammonium ion plus hydroxyl ion. Ammonium hydroxide, NH4OH, it will ionize. Reaction you have to write NH4OH is equal to ammonium ion plus OH ion. Then now, how much total hydroxyl ion, how much? Here, but here first understand that NH4OH, actually if you calculate 2.5 millimole, 2.5 millimole if you convert in molar mass, it will come 0.333, 0.333, okay, it will come. Then here 0.033, only 2 digit to consider, that is the total solution became how much? 50 ml plus 25 ml, 50 ml ammonia, 25 ml acid you have mixed, then total solution is actually 75 ml. In that ammonia is remaining 25, that is a 2.5 and 2.5 ml a millimole, 2.5 ml ammonia was there, that is a 2.5 means 0.033 millimole. Then out of this this ammonium hydroxide 0.033 m is there, millimole converted into molarity m, okay. Then suppose in the beginning, not suppose, it is given 0.033 m. Then in the beginning there was no ammonia and no OH ion. I am talking about the remaining ammonia. What it will do? It will react with water, it for ammonium hydroxide. Now second equation you have written ammonium hydroxide is equal to ammonium ion plus OH ion. Then in the beginning there was 0 ammonium, 0 hydroxyl. But at equilibrium what happens? Suppose out of this 0.033 m, Y mole reacted, means alpha dissociated, then Y mole ammonium will form and Y mole OH will form. Then now at equilibrium, how much ammonium hydroxide will remain? Then 0.033 minus Y will remain, and Y mole of ammonium and Y mole of OH ion. Then now how much total ammonium became? Then total ammonium became now Y mole ammonium, and in the beginning first expression you have written, that was 2.5, then that 2.5 and this Y, then total ammonia became 2.5 plus 5, okay, 2.5 plus 5, and this is the total ammonia, okay. Then now here total ammonia is 0.033 plus Y. Then now again you know that you are going to apply again Kb expression. Second time you are going to apply Kb is equal to products divided by concentration, that you are knowing. Then here Kb value you will write ammonium ion concentration. Now it is 0.033 plus Y, and OH ion concentration, that is into Y, okay, means 0.33 into Y, that is the for product, divided Y, now 0.033. Why like this? Actually you have calculated 0.033 plus Y total ammonia, but this Y is very less in comparison to 0.033, because Kb is very less. Then whatever is with some value, if Y is attached, means alpha is attached, that you can neglect, either upside or down. Then down also it was 0.033 minus Y, then that minus also y also you can neglect. Then now down it will remain only 0.033 and upside 0.033 plus y into y was there, that is was for OH ion. Then OH ion that will remain, that you have to consider, but 0.033 plus y, that y will go. You can neglect it. You can neglect it because that amount is very less. Then now you will get Kb is equal to 0.033 into y divided by 0.033. Then this both will cancel. Then what is the Kb value? That is equal to y. Then y means OH. Y means OH. Correct? Y means OH concentration now you are knowing. Then when you are knowing OH concentration, sorry, your intention is to find out pH. Then OH now you are knowing. Hence again same formula you can write, that is H ion concentration into OH ion concentration, that is equal to 10 to the power minus 14. Then OH ion concentration now you got it. Okay, you got it. Then that is a 1.77 into 10 to the power minus 5. Then hydrogen ion concentration, easily you can calculate hydrogen ion concentration, that will become 0.56 into 10 to the power minus 10 to the power minus 6. You will get 10 to the power minus 6. Then you will get pH value. pH value will get pH is equal to 9.24, means solution finally became basic. This hydrogen ion concentration you are knowing, then OH ion concentration you are knowing, then H ion concentration easily quickly you can know, 10 to the power minus 14 divided by OH ion concentration. OH ion concentration calculated. Then now pH value will get 9.24. Today I am stopping only here. Next class again we will meet you. Thank you.